I wanted to go over how you can graph functions in Desmos if you have a particularly complicated function. So in homework 1.1, question 13 is what we call a piecewise function, in that it has three pieces in terms of its entire definition. So like sometimes it's equal to 1, that's if you're less than or equal to 2. Then it's equal to 8 over x if you're strictly between 2 and 4, strictly meaning there's no equal sign. And then if x is greater than 4, it's linear, and in fact it is 6 minus x. So you can actually graph this thing in Desmos. So I want to start by setting this up. So the function's called g of x. So over here, I'll just put g parentheses x, close parentheses, and I'll hit my equal sign. Anytime that you're defining a piecewise function, you can start by putting in a curly bracket. And step one is to first put where you want the function to be defined. So by that I mean, there's this if x is less than or equal to 2. So what I'm going to put here is x is less than or equal to, so I hit the less than sign and then the equal sign, and I put 2. You have to put a colon followed by the number 1. And look at what appears on our graph. If you're at 2, and in fact equal to 2, we're assigning it 1. If this condition was not here, you would have just gotten a horizontal line of 1 forever in both directions. To enter the next part of your piece, you can put a comma. Okay, so for the next piece, if I go back to the function itself, we're now strictly between 2 and 4. So I'm going to put this condition next. All right, so I'll go back to my function. I'll put 2 less than x less than 4. So that's my condition. I'll put a colon to indicate that I'm going to now define my function. The function that we want is 8 over x. So going back over here, I'll do 8 divided by symbol x. It actually automatically gives me a fraction. Then you can click over, and that defines the next part. So here it's equal to 1. Here we have the function 8 over x. And finally, we now want to graph 6 minus x if 4 is less than x, or if you'd like, you could say x is greater than 4. I'll go back here. Again, I'll put a comma. I'm going to enter my condition of x is greater than 4, or I guess you could do what they have, which is 4 is less than x. I'll put the colon, followed by what the function should equal there, which is 6 minus x. And then I'll end this, because that's the end of the function, with my curly bracket. And you can move this over so we can view the entire function itself. But here it is. Like, here's the function. It's this horizontal line. It then jumps up to this rational function, and then it's a decreasing linear function going in this direction. So putting the function back over here, it's kind of complicated because it has several parts, but it is possible to graph these types of functions. I'm actually going to go a step further here. You can actually add what's happening at these places for emphasis. So like, for example, we put that for x less than or equal to 2, the graph is equal to 1, but it's kind of hard to see what's happening at 2 itself. It should actually be the point 2, 1. And it's very easy to add a point to your graph. So like directly below here where it says 2, I'm going to open parenthesis, put 2, 1, close the parenthesis, and it puts a point there for emphasis. If you click over here, you can hold down and then change it to blue so it matches up with the graph. And then for emphasis up here, if you want to say like, okay, the point does not exist here, there should be a hole in the graph, and that's at 2, 4. Okay, you could do 2, 4 to enter your point. Hold down here, so click and hold. Try that again. Change it to blue. But there's these other options here where you can put this open circle. So it exists at 2 because it equals 1 at 2. but then there should be a hole at this point on the graph. And I think the last point here that we should focus on, if I go back to the way the function is defined, it doesn't equal anything at 4. There's no equal sign next to a 4 whatsoever. This means there should actually be a hole in the graph here at the point 4, 2. So instead of entering that in again, here where I have this open circle, I can put a comma and then just start listing another point. So that other point is 4, 2. And it can just list another one over here for you. So I'd say, this is quite a bit. It's a long way to go, but this would be the graph for this function that appeared in question 13 in section 1.1.